Right, so yeah, hi. I'm Munn. So I work for a company called Focusrite Innovation. We make iOS apps to make music with. That's my GitHub address. You can be friends with me if you want. So I'm gonna give you some tips for that. These are like lessons I've learned in the last sort of couple of years using various CI tools. Like for Node and Docker. So yeah, here we go. So what is continuous integration? So it's about checking commits can integrate with the current system. So it's important for, especially in like a microservice architecture, to ensure that like contracts are kept between services. And it's about alerting development teams of failures as quickly as possible. Failing fast, avoiding expensive mistakes making their way out to users. Then the CD part is continuous delivery, which is about encouraging a smooth, automated deploy process, like regularly deploying small changes to production, and again, alerting development teams of failures as quickly as possible. It reduces inventory so that like you don't have undeployed code, because that's expensive, that's an asset. And it allows the developers to add value frequently by releasing features and fixes continuously. What tools can you use for CI/CD? So I've got a few there. I'm sure there's a few more. So you've got things like Jenkins and TeamCity, which are kind of a bit more traditional. You've got like, usually you run a server and an agent or multiple agents, or slaves they're sometimes called. And these slaves run your builds, your compilers or tests, whatever you need to do. And then the Circle and Travis are kind of more on the configuration as code, SAS kind of idea. I haven't used Go that much, but I imagine it's probably the similar kind of idea. So configuring your tool. So you decided to use CI. First tip I've got for you is keep your agents lean. So the first place I ever did continuous integration at, we were using TeamCity, and there was a massive Git repository called TeamCity Build Tools, which had about 3 different versions of Ruby in it. It had various tools, PowerShell extensions, anything you can name, and basically we would clone this repository onto every agent, and it would take hours and inevitably be not at the same place in all the agents. So basically this is the kind of situation that happens. So you start a CI system, you're like, okay, I'm going to write one project. So I've got a team, and my project's in Git. It's a Node 4 project, and I'm deploying it to App Engine. So install Node, install Git, install App Engine, and I'm away. Then Team B comes along, and they're like, oh, we kind of like what you're doing. You're deploying things quickly, and you're, we like the CI idea, we want to implement it as well. So we're going to use your CI server. Except their app is using ImageMagick, and it's in Python, and they're deploying to servers using FTP, like old school style. So now you've got all these things installed on your agents, and Team C comes along and they're like, well, we want to adopt this as well. So they go, well, we're going to write our app in Node, but we're brand new, so we're not going to use Node 4, we're going to use Node 7. So then you've got this problem. So you're going to have to install 2 versions of Node on your agents or slaves, or you're going to have to install something like NVM or N to manage these versions. And basically you could go down that route, but you eventually will install everything. And especially when you get to things like browsers, wanting to run tests inside various browsers, and you have to install different versions of Firefox and Chrome. And installing a new build agent when you need to add another team, because you've got 2 build agents can't run builds for every team in the world. And then you've got Snowflake build agents because you've got an unmaintainable list of software to install on there. It's hard to scale this. It uses more resources, basically, as your company grows, you'll have more agents to keep up with the demand, and they have so much software installed that they'll take ages to configure, and your ops team will hate doing it, and it will become unloved. Also, agents will need loads of space to handle all the dependent software. So, some solutions to this. If you're using Node, just install your packages locally. So a lot of NPM pack modules, things that spring to mind are things like Babel and Grunt will go, you need to install this globally with the -G flag. Don't listen to them, basically. You don't need to have that globally. Have everything defined inside your repository in your dev dependencies, and so it's local to your application. Inside your repository, you've got a definition of everything you need to run. This doesn't just apply to Node. If you're using Python, virtual env, or NuGet for C#, or there's lots of ways you can define your dependencies inside there. Then scripting the agent configuration process is a good minimum sort of thing to do. Whether it's just a bash script or using Chef or Puppet or something that can take an empty machine with just the OS installed and install everything you need to do for your development teams to run their builds. Problem is that they only solve part of the problem. So it kind of depends how your infrastructure is split in terms of people and management. But you don't really want every time your app requires a new piece of software installed to have to ask a sysadmin to install something new on all the agents, because they're not going to want to do that, and you want to be able to be quite fluid with that. So suggest moving it over to the developers and only install Docker and Docker Compose on your agents. Everything else can be down to the developer. And like I said, that forces you to bring all your dependencies inside your repository and developers to think about what is needed for the runtime of this app. So tip number 2, keep your configuration in source control. A lot of CI servers like TeamCity basically all of them are built to support a million different types of build tools. You've got things to support Maven, you've got things to support Ant, you've got things to support NPM, you've got cron jobs defined, zip file expressions, all sorts of crazy shit. So it all sounds great when you first discover it and you're oh, this is amazing, I can do so much stuff with it. But and you don't really think about that at first though. You'll just start with something like this. You'll have check out my source code and run this. npm install, npm test, and deploy. So then you go and discover that all these plugins exist. And then you'll go, okay, well, I want my build to run at 9 a.m. every day. Why not? So that I know I come into work and I know that it's working. And then I've got a database and I want to configure some canned data, and my CI tool has got a nice plugin to help me do that, so I'll use that. Then I'll check out my source code and then run my build steps as I described before. And then I found there's another great plugin that reports great test output, so that I can know exactly where my code failed. And then I'll go, oh yeah, there's a plugin that also emails people when there's a release that happens. So that's really great, people will be aware that things is going on. And then another plugin that zips your built source code and stores it somewhere to archive or whatever. And then there's some other super awesome plugin that is absolutely critical to make a release functional and is only available on the CI server. So that's all great, and you're like, I'm a pro user of Circle now, or whatever. And then one day, this happens. So you hit your CI server, and there's nothing there. So this happened to me before. It was a day where, for one reason or another, all the source code disappeared from the production servers. Let's say a fat finger error. And at the same time, the CI server went down, so we couldn't deploy. And because a lot of the logic to tell us how to deploy was on that server. So first thing to get back to live was bring this back up, and then before we could deploy. So it was a lot of time wasted when we were down, where we couldn't do anything. So solutions to this: keep all your logics in scripts or a task runner. As tempting as those plugins might be, keep them in source control. And commit. So a lot of CI tools have kind of know about this problem now, and they offer solutions for this. So Jenkins has this thing called Jenkins pipeline script, which is like a little groovy script which allows you to define each step inside a file which you commit with your source code. Circle has got a YAML file, so does Travis. I think TeamCity has got an XML file to do the same thing. Basically, I recommend, although you can have a Maven task of this task or whatever, just keep it to small command line scripts that will run efficiently and that you can commit. So tip number 3, avoid NPM bloat. So, you've decided to be like a JavaScript ninja, and you've read about Node, and you want to use Mocha because you love test-driven development, and use latest JavaScript features. And then you're going to use a task runner like Grunt, and also you love static typing now, so you're going to use TypeScript. And you've Googled all of this, and then the best way to make a web app, it tells you, is to run this magical command. So that's before you've written any code. So yeah, that looks pretty inoffensive at first. But let's look at that. So this is my internet connection at home, which I think is pretty good, to be honest. 50 meg a second. I'm quite happy with that. So on that connection, it takes 10 seconds to download to run that command, that npm install command. So that's 50 megs of node modules, right? 199 different packages and 4,086 files. So I don't want to tell you how many contributors and how much code, potentially buggy code, there is in that. So to start a small web project, there is no need to do that. Solutions to this is, please spend a bit of time learning Node core. To write a web server in Node, it's those 5 lines of code, right? So if you just need an API to return you some JSON, static JSON, that will do it. It will also make web requests. At first, you don't need a million packages to do that. So yeah, install modules as you need them. So the whole Node ecosystem is built on the Linux philosophy of bringing small things together. Avoid massive frameworks. So my experience of Angular 2 and Ionic is just an absolute blasphemy. Start with lightweight modules and solutions. So here I've got some alternatives for you. So you need to make some web requests. Well, request is 6.3 megabytes. You've got Needle, which does most of the work for you, unless you need to do OAuth or range requests or anything complex like that. That will be perfectly sufficient. Arva, really popular testing framework at the moment, but look, it's 34 meg for Arva. Tape has got the same API, 2 meg. So start with Arva, and then start with Tape, and then you can migrate to Arva really easily. Again, Router versus Express is maybe a bit overkill, but it's also another example. I mean, this is if you're just building an API and you don't need to like render like complex views or like do compression and cookies and all this stuff, like having just something that routes web requests is fine. Also, a build tool. So start with NPM scripts. It's built into NPM. You don't need Broccoli. You don't need Grunt or all these things. Like just start out small and see where you go from there. Also, something else I've seen people do is using boilerplate projects, like especially things to do with client-side code, like React and Angular. You go and look at a React boilerplate project, and you'll get every module under the sun that you won't need. Just start small and build on what you need. Tip number 4. So keep your Docker images lean. So large images take up unnecessary disk space. They take a long time to build and deploy. And having more software installed means that more things can go wrong. So basically you can, your storage costs will increase. And sort of continuous delivery is about getting change out to users as soon as possible, so you get fast feedback. You don't want to be waiting to ages for Docker images to build. Having more software installed on your images means that more things can go wrong. So this is just a suggested workflow that I've found works. I didn't invent this. I think a lot of people are doing it. So it's about having 2 Docker files. You have one for development. So here you have a node-based image, and you add your package.json, and you add your app, and install, and then run your build. So here is the explanation of the first line. So if you're not familiar with Alpine, it's a very lightweight Linux distribution. The default node.js Docker image is based on Debian. So as you can see, it's quite a lot larger. Quite a lot you're going to have to wait to download more than downloading Alpine. So I recommend basing it on something like that. The next important line is this. So add your package.json first. So this basically takes advantage of the Docker cache. So what happens is you add your package.json and you build this Docker file, right? And then next time you build it, if you haven't changed your package.json, it will skip over it all the way up to add app. So that means that you've cached the npm install step, which takes a long time. So it will only run npm install when your package.json changed, which is usually when you add a dependency. Okay, maybe you'll run it a few more times if you add an npm script, but this saves you a lot of time. It means you don't have to do npm install every single time. That's probably, if there's one thing you take away from this talk, I think that will speed up your builds the most. So in production, you want to deploy the smallest possible artifact to your production servers. So again, node Alpine, then add, so dot here is a directory with your built application, everything just for the runtime. So I mean, your dev dependencies removed, your npm packages deduplicated, your tests deleted, anything that's not required to run your application should not be in there. So then the build steps for this kind of workflow. So build your development Docker image, run the tests inside the development container, and like I said, remove the runtime specific files, non-runtime specific files, and publish your production Docker image with your built artifacts, and then run some smoke tests on your test environment and repeat in production. So this is now kind of obsolete because as of Docker 17.05, there's something called multistage pipelines, which I haven't tried yet, but it's basically allows you to, inside a single Docker file, base lots of little images from one Docker file. So you can do the build container and then at the end up with just the production container, just all in one descriptive file. So that's quite a new thing. I haven't used it yet, but I'm quite excited to try it out. Final tip is use Docker Compose. So say you're building a website and you want want to run some tests using Chrome. So then that website also reads from a database and talks to an API and talks to a queue. So if you have to wait to deploy to a test environment to test integration between all of these things, I mean, that's slow. Basically, anything that involves having to deploy your application, it will take longer. So like with Docker Compose, you can have a truly like local environment running all of these things and test locally before you deploy anything. And you can also use it for local development. So here I've got, this is taken from an application I built a few months ago. So it's an application that talks to the OpenShift API. It's basically an API router. So those services and SSL service are just dummy APIs. The API is the application itself. And then the tests is a container that runs web requests against the API. So as you can see, so with the links at the bottom, it means that this container can talk to those two containers. And it's basically a very descriptive way to like describe your entire environment and run quite a comprehensive suite of tests, acceptance tests, like before you have to deploy, as I said. So some other tips, get a build monitor. Like it sounds obvious, but it seems like a lot of people don't have one these days. Like just having people see something red is just like a really good visual cue, and it will help you. Integrate with pull requests. So GitHub and GitLab both allow you to like run a suite of tests or some kind of CI check before they let you merge things. So, you know, like there's no point in doing a code review for code that doesn't work. So I'd rather know, well, go and fix your test and then I'll review your code. So Yarn again, like it is quicker than NPM, so I recommend trying that. And try running your tests in parallel. So yeah, that's it from me. Does anyone have any questions? At what point should you like look to implement this kind of thing? Like, and what are some telltale signs that your current system is slow? So yeah, I mean, it's really an iterative process. Like I didn't sit down and go learn all of these things straight away and build it at once. So like, it's about like, you want to spend as little time maintaining your build process as possible. So like, if you find yourself like spending time like massaging builds through, like rerunning builds because they're red, waiting for them, like look for little things, like while they're running, look up ways you can make them faster and just like constantly improving on what you're doing. I mean, like this isn't the end. Like there'll be loads of other ways to optimize things. So yeah, I think it's just constantly improve. How long do my builds take? Well, right now, yeah, my builds take about 30 seconds because there's no tests. I've just joined somewhere new, and they didn't really have CI until about a week ago. So I think it's a bit of an unfair question. I guess after a year, if you've got end-to-end tests that are taking a long time, like it's more, you want to start looking at the tests that you have, and like obviously you should have a lot of small, fast tests and fewer slow tests at the end. So maybe it's time to look at the test suite and try and like reassess like what's the best way of testing these things. In terms of if it's NPM installs that are being slow, another thing that can speed things up is having your own NPM registry. So the main NPM registry I think is only based in the US. So when you're doing a lot of NPM installs, that's very slow. So I can't remember off the top of my head, but there's a few solutions to installing a local NPM registry that are like, if you're running things in AWS, you can run it inside your own VPC. And that speeds things up a lot as well. But yeah, it sounds like reassessing like how you're testing things and like looking at that kind of thing is probably the way to go.
Cool. I think that's all the time we have for questions. Let's give another round for Will.